Now, DP produced meets AB produced at point L. Okay. DP produced. You all know what is the meaning of the word produced in maths, right? Especially in geometry. Huh? Produced means extended further. Produced means extended further. So here DP, where is DP? DP is over here. This is D, this is P, and let me connect both the points D and P with a line segment. So that becomes line segment DP. DP produced. That means the line segment DP has been extended further. So you can extend this DP further like this, isn't it? You can extend this DP further like this. The blue color line which I have drawn, that is what the DP produced further or DP extended further. Now what is happening to that extended portion? It is meeting, children, it is meeting AB. Where is AB? Here is your AB, right? So the DP produced, in this case, the blue colored line which I have drawn is intersecting AB produced. AB was also getting produced, children. So what I'll do is I will extend this side AB further. And you will notice that both DP produced and AB produced are intersecting at a common point of intersection. Right? Where is that point? Let me assume it to be A, B, C, D, P. Let me assume it to be Q. Easy? Wherever AB produced and DP produced are intersecting each other, I'm considering that common point of intersection as what? Point. Oh, they have already given you the name. Okay, if they have already given you the name, let's give it the same name, right? L. All right. Now, what they are asking us to prove? They are asking us to prove DP is to PL is equal to DC is to PL. Let me write here. The first thing which we have to prove is DP is to PL is equal to DC is to BL. When you write it in the ratio form, you don't get a clarity, children. Because personally speaking, I never get a clarity what I need to show. So what I usually do is I write it in fraction form. DP upon PL is equal to DC upon BL. I write it this way and then I get some more clarity. Like, when compared to the previous ratio format, I get much better clarity in this. DP upon PL is equal to DC upon BL. So, I understand DP and PL. They are the ratios of the corresponding sides of two similar triangles. Then DC upon BL. That is also the ratios of, the ratio of the corresponding sides of two similar triangles. Now, I need to first of all determine this DP, PL, DC, BL, all these belong to which triangles? Because see, if you have to show the ratios of corresponding sides are equal, before that there is a hurdle to be crossed. What is that hurdle? Proving similarity, isn't it? You have to prove similarity in between two triangles to which this DP, PL, DC, BL belongs to. Unless you don't prove similarity, how we are going to write the ratios of corresponding sides in proportion? Check. Proportion. Right. How will you show that the ratios of the corresponding sides are in proportion? It's not possible. So our first task is to show similarity between those two triangles. So from here, I think DP is a part of triangle DPC. PL is a part of triangle BLP. Then PL, then DC. DC is a part of triangle DPC. Then BL, that is also a part of triangle BLP, isn't it? So I got a fair enough idea that the triangles which I need to take in order to prove similarity are triangle DPC and triangle BLP, right? I will just highlight it in white color. These are the two triangles. First, I need to show similar. Okay. So once you decide the two triangles, you can use them either in the original figure. You want to use two separate triangles so that it becomes easier for you to figure out which are the corresponding vertices. You can do it that way also. Okay, now that is totally your convenience, children. I will never interfere into that. Okay, I will never interfere into your calculation techniques. Arthur, can you hear me? I just saw your message in WhatsApp.
Yes, sir.
Okay.
I'm having some internet issues.
You could have come for
I'm staying
offline
in a
class.
different room. So I'll come from Monday.
What happened? You are not really feeling well?
I had a viral fever.
Viral fever. Okay, doctor. Now, how to show similarity between these two triangles? Children, I'll take some extra time to make you understand this. Huh? They are talking about a parallelogram. So unless you don't know the basic properties of parallelogram, proving similarity becomes a little tough. Okay, so that is the reason I thought I will discuss about the basic properties of a parallelogram first. Jeevan, look here. When I say ABCD is a parallelogram, I mean the opposite sides are equal as well as parallel. You all know that. Children, when I say the given figure is a parallelogram, indirectly I'm telling you that the opposite sides are equal as well as they are parallel. So AB and DC are equal as well as parallel. One more thing, side AD and side BC, they both are parallel as well as equal. So remember this in one single sentence, the opposite sides in a parallelogram are parallel and equal in length. Okay. Now, one more thing. Always remember the opposite angles of a parallelogram. They are always equal. What did I say? The opposite angles of a parallelogram are always equal. So angle A and angle C are equal, and at the same time angle B and angle D are equal. Okay, class 8 we had understanding shapes. In that chapter we had learned this concept. The opposite angles in a parallelogram are equal. Milan, just reduce the fan speed. Now, one more important concept. Suppose yes, enough. Thank you. ABCD is a parallelogram. Hmm? I am extending this line AB further. Say for example, BE. Okay. From this point D, imagine I am drawing a line segment. From this point D, I am drawing a line segment DE. Okay. If I ask you, if this angle is 34 degree, how much would be this angle? 34 degree. And what reason you will mention? Interior alternate angles, isn't it? See, the reason is these two lines are parallel to each other, that you know very well. Huh? And if I draw a transversal from this point till this point, this yellow colored line which I have drawn, that becomes the transversal, isn't it? So the angles formed on either side of the transversal in between two parallel lines are always equal. Why? Alternate interior angles are always equal between two parallel lines. Just remember this fact. Okay. Then one more thing. Suppose there are two intersecting lines. This is not at all related to the concept of parallelogram. This is just a basic property of intersecting lines. When two lines are intersecting at this point, what are these two angles called? Vertically opposite angles. And you all know vertically opposite angles in between two intersecting lines are always equal, right? Now we are going to make use of these two properties or these two concepts. I'll do one thing, I'll just erase all the white color lines inside and then restart solving this sum. Yeah. Now don't you feel this angle DPC and this angle BPL, they both are equal. They both are equal because they both are vertically opposite angles, because it originated at the point of intersection, right? Second point, Children, can't I say that these two angles, are also equal because they are alternate interior angles? Yes, we can say that they are alternate interior angles and they are equal. You had to show any of the two angles to be equal in between two triangles. Automatically, the given two triangles become similar to each other, right? So here, children, we have already shown that these two triangles are similar. We just need to write the statement and the reasons. Hmm? So what is the first point? It is angle DPC is equal to angle BPL is angle to BPL, and the reason is vertically opposite angles. Why? Because they are vertically opposite angles. Make a note. Point number 2. We can say angle PDC. Angle PDC is equal to what? Angle PLB. Why so? Because they are alternate interior angles. Alternate interior angles. Two of the angles are equal. Now we can show that they both are similar to each other. So how you want to name it? Triangle DPC. Triangle DPC is similar to triangle dash dash dash. What would be the corresponding vertices? Let's find. Children, D was, see here only we have written. D was corresponding to which angle? L, isn't it? This angle D, PDC. If you notice, PDC was corresponding to whom? Angle PLB. So D is corresponding to whom, children? It is corresponding to L. So the first letter would be L. Second letter, in angle DPC and angle LPB, I think the angle which are equal is P. Don't you feel so? Huh? P corresponds to P. So here I will write D, right? DPC and LPB. Yeah. It's correct. No? DPC is similar to triangle LPB. Is this correct? Just let me know. Purva, Caitlin, is it clear? Janice, Maria, Freddy, Harni, Amal, Ron, just let me know. They both, Caitlin, very good. Yeah, LPB. Now, please don't forget to mention the name of the axiom, which is angle-angle axiom. Sachin, is it clear? Corresponding vertices? Okay. Ron, Gautam.
Yes, sir.
Yeah. So DPC is similar to triangle LPB angle-angle axiom. Now, children, whenever the sums are based on the ratios of its corresponding sides, I have taught you, please make use of the thumb rule blindly, isn't it? Whether it is useful or not, we will think later. Even if you write it in the paper, nobody's going to cut your marks, right? So blindly, you just write the ratios of the corresponding sides in proportion. So the fourth statement would be what? Side DP upon side LP. Side DP upon side LP is equal to side PC upon side PB is equal to side DC upon side LB. Right? You have written the ratios of the corresponding sides in proportion. Now things are getting easier. Now what they were asking us to show? They were asking us to show dP upon PL is equal to DC upon PL. Are we getting it from this result? dP upon LP or dP upon PL, both are same, is equal to DC upon BL. You write it as LP or BL. That does not make any difference. Yesterday also I taught you that. Yesterday or day before yesterday, isn't it? You call it as line segment LP or line segment BL. Technically, there is no difference, isn't it? Because the distance from me to Milan and the distance of Milan to me is the same, right? So whether I call it as distance Isaac Milan or distance Milan Isaac is the same thing, no change. All right. So let's take these two ratios and write the required result. which is DL upon LP, is equal to DC upon LB. Hence proved. Yes. Hmm? DL upon LP. LP. That's what I said. You write it as LP or BL. So DP. Acha, acha, over here. This one. Okay, okay. Thank you. DP upon LP is equal to DC upon LB. Easy. Yeah. Now one more you have to show DL upon DP. DL upon AL upon DC. I think we have to make use of the original figure again. Right. Okay, we'll show. Children, when we start solving prove that sums, especially when there are no numbers, the class's atmosphere automatically goes dull. Okay. And that happens every year with me and the students also. So you please try to keep yourself inspired. Huh? This happens just once in a blue moon when we have to do prove that sums. Otherwise, all the sums that we practice in ICSE maths is numerical sum, isn't it? So this is one of the rarest occasions where we have to deal with such prove that sums. So don't feel sleepy and don't feel low. Okay, because going forward, we are going to solve a lot of numerical based sums in the very same chapter. All right. Yeah. So we have to show DL upon DP is equal to AL is to DC. How is it possible? AL is to DC, DL upon DP. Okay. We'll do one thing. I'll just copy paste this question on the other slide and let's start doing it from the beginning. Here is the question. The other diagram is so clustered, I won't be able to explain it. Huh? So let's draw it again. What they had given? A parallelogram, right? So this is your parallelogram, which is A, B, C, and D. They were talking about DP being produced for the DP being produced further, it will touch L. Okay. Now they are asking us to prove what? They are asking us to prove DL is to DP is equal to AL is to DC. We need to prove this. So if for a better understanding, do one thing. Just write DL upon DP is equal to AL upon DC. Again, it is looking like the ratios of the corresponding sides in proportion. We have to first of all figure out, in order to reach here, which two triangles I have to take and prove similar. Otherwise, Johan just open. Okay, we have to decide which two triangles we need to take. You only tell me, children, DL. DL belongs to which triangle? I think it is DLA, isn't it? The whole of DL will belong to which triangle? Triangle DLA. Okay, fine. Then DP. DP is a smaller side, yeah. Then AL. AL also will belong to which triangle? The big triangle. Okay. Then DC will belong to which triangle? This triangle. All right. We'll do one thing, children. If in this whole figure, DP is there, then AL is there, and then DC is there. Okay. AL, ALD and DPC, that will not help because you won't be able to prove that they both are similar to each other. Which one? ALD and DPC? They are similar. How? No, AL is not equal to DC. Because huh, this way, angle A and angle C are equal. And these two angles, yeah, this way also you can do. Yeah, alternate interior angles are equal, no? So you can go with this. The first property which we learned, opposite angles in a parallelogram are equal, right? Let's give it a try, children. If it is working, good for us. This will work. Why not? So this is your first triangle. I mean the smaller triangle, D, P, and C. Okay. Then this is your bigger triangle, which is DLA. Okay, this is the bigger triangle DLA. Okay. Now, as mentioned in the diagram, children, you know this angle A. Now, you know this angle A and angle C. They both will be equal. Why? Because you know in a parallelogram, the opposite sides are always equal, right? The opposite angles are always equal. So angle A will be equal to whom? Angle C. Now, if you notice this angle ALD, children, the one which I'm highlighting in white color right now, that is angle ALD. And if you notice angle PDC, the one which I'm highlighting right now in white color, that is angle PDC. Don't you think they both will be equal? Because you know DC and AL, they both are parallel to each other. If two lines are parallel, then the alternate interior angles of both the parallel lines should be equal. So can't I say if this angle ALD and this angle DPC, they both happen to be the alternate interior angles, right? Common angles. No, they are not common. Not common. In this situation, they are alternate interior angles. Okay, so for your reference, what I'll do, I will label this angle as X, this angle as also X. Then I'll label this angle as Y and this angle also as Y. Two of the angles are equal in both the triangles, hence you can say that they are similar to each other. Now let's write the reason statement and the reasons. All right. So the first point would be what? Children, the first point would be angle. You just write down the name of the triangles which are going to prove similar. That will be highly advisable. Okay. Which two triangles? Triangle ADL and triangle DPC. Now you randomly name the two triangles. At the end, when you write the notation form, you will be giving them proper name as well as the corresponding vertices in a proper order. Okay. So here, first point would be angle DAL is equal to angle DCP. Make sense? This angle and this angle, they both are equal. Yes. So angle DAC is equal to angle DAP. What would be the second point? Second point is angle CDP, isn't it? Angle CDP, this angle. Angle CDP is equal to what? Angle PLB or PLA. Just look at the diagram, children. You will understand how I am naming the angles. Did you all follow this? Angle CDP and angle PLA are equal. I always recommend you not to write, children, not to write the name of the angles with only one letter. Okay, please do write the name of the angles in full format. So here you are, here you are doing with angle PLB or CDP. This is your CDP, right? If you're doing with your CDP, don't only mention angle D. You should mention it as what? Angle CDP. And on the right hand side, if it is PLB, okay, if it is this angle, then don't mention it as only angle L. represent it as what? Angle PLB. Okay. Point number 2 is done. Now, point number 3 is writing the similarity of these two triangles in notation form. How can you write it? So point number 3 would be triangle. Which triangle you want to take? DCP or DPC? Triangle DPC is similar to triangle dash dash dash. Children, D is corresponding to whom? L. So L will come in the first position. Then P is competing with whom? We don't have an idea, but you know what is C corresponding to? C is corresponding to A. So that will be the last position. Now, let us write it in the proper form. DPC is similar to triangle LDA. And that is coming from angle-angle axiom. Easy. That is coming from angle-angle axiom. Understood, no children, everyone? Online students, Rian, Maria, Freddy, Sandra, Nabil, Ron, Gopika, Gautam.
Understood, sir.
Yes, sir.
What about-
Understood.
So angle CDP is equal to angle PLA and then DPC similar to angle LDA. They both are similar according to angle-angle axiom. Now, once you show similarity between the two triangles, we need to write the thumb rule, isn't it? Once you write the thumb rule, you will get the end result. See, I'm going to do that now. You know, triangle DPC. I'll write it once again. Triangle DPC is similar to triangle LDA. So DPC is similar to LDA. Which are the corresponding sides? DP and LD. Right. So I will write DP upon LD is equal to the next one, PC upon DA. So I can write PC upon PA is equal to DC. The first and the third is to first and the third, which is LA. Okay. Now this is not the required result. We need only DL, DP, AL, DC. So DL, DP. DL is over here, DP is over here. Then AL is over here and DC is over here. So children, from these two, I can write DP upon LD is equal to DC upon LA. Now, shall I cross multiply both the sides? Still, you're not getting, no? No need to cross multiply, right? DP upon LD is equal to DC upon LA. Okay, children, the result which they have given, if you notice, that is just the reciprocal of what we have got. See this, here we have got what? DP upon LD. But in the result, what they have given? DL upon DP. Okay, here what we have got? DC upon LA. And here what we have got? LA upon DC. So just the reverse is what we have to prove. So very simple, children. On this, just apply invert into, isn't it? If you apply invert into, what you will get? DL upon DP is equal to what? AL upon DC. Are you getting it? Children, can we take the reciprocal of both the sides? Now, if you suddenly don't remember the term, this one, invert into, just write reciprocal of both sides. Reciprocal of both sides. Will you please mention this? Reciprocal of both sides. So when you take the reciprocal of both sides, what do you get? What will you get? LD upon DP is equal to LA upon DC. Hence proved. All right. Children, is very theoretical, no? Was I able to convince you? How two angles are equal, how they are similar, angle-angle axiom, then writing the ratios in proportion. Okay. Shall I just take a 5-minute break? Because even I want to drink some water and stand for a while. I'll just take a short break and come. Okay. In the initial stages, you will get all these prove that sums. If it is number-based sums, it's so interesting to solve. Otherwise, it becomes quite boring. for both the teachers as well as the students. Okay, let's start. In a quadrilateral ABCD. In a quadrilateral ABCD. So it is a quadrilateral. We don't know what type of a quadrilateral is. It may be a square, it may be a rectangle or a rhombus or a parallelogram or a kite. I have no clue about it. So since they have used the word quadrilateral, I will be drawing it in such a way that it is irregular in shape. Okay, somewhat like this. I have drawn a geometrical shape which is having 4 different sides. A, B, C, D. You can draw the quadrilateral in whichever way you are comfortable with. Okay, not compulsory that you have to follow the same figure. But 4 sides should be there. All right. Now what they are saying, the diagonals AC and BD intersect each other at point O. Obviously, in a quadrilateral, you will have 2 diagonals, right? Now they both are intersecting, children. They both are intersecting. So let me draw the 2 diagonals. One is AC and the other one is BD. They both are intersecting. Now, where are they intersecting? They are intersecting at point O. Okay, they are intersecting at point O. Now, if AO is equal to 2CO, AO is equal to 2CO. Where is AO? This one. This is your AO. And where is your CO? CO is this one, right? This is your CO. They have given you a correlation between AO and CO. What is the relation? AO is equal to 2 times CO. So children, can't I say the ratio of CO and AO is equal to 1/2 or 1:2? Right. Children, when you bring those terms to the left hand side and right hand side, please be careful. Because I have often seen they will write CO upon AO is equal to 2/1. No, it's not 2/1, it's 1/2. Because you are bringing this AO to the right hand side denominator and you are bringing this 2 to the left hand side denominator. Isn't it? Albina, is that clear? Then 2/1. Then 2/1. Yeah, that is your choice. Okay. See, what I'll do is I'll bring AO to the right hand side denominator and 2 to the left hand side denominator. So it becomes 1/2 is equal to what? CO by AO. Easy. Otherwise, you simply write it as CO by AO is equal to 1/2. Simply, they are trying to say the ratio between CO and AO will be what? 1:2. Okay. Similarly, children, they are saying BO is equal to 2DO. If you notice, BO is equal to what? 2DO. So where is BO? This one. This is your BO. And where is your DO? DO is over here. Now they are telling you BO is equal to 2DO. The same way as I did in the previous part, BO is equal to 2DO. I can write DO by BO is equal to 1/2. So the ratio between DO and BO is what? 1:2. Okay, fine. This was the given data. Now, children, there must be some purpose behind giving this data, isn't it? For no reason, they are not going to mention such important correlation between AOCO and BODO. There must be some purpose behind it. Let's figure out what is that purpose. Okay. And always the data given to us in this chapter will have the same purpose. That is proving similarity between 2 triangles. Okay. That is proving similarity between 2 triangles. Once we show similarity between 2 triangles, you can get the desired results. Okay. In this case, what is the first result that we have to bring? Triangle AOB is similar to triangle COD. This is what we have to prove first of all. So let me write the question here. Question number 1. To prove triangle AOB is what? Similar to triangle COD. Now, once you get the question, compare it with the original figure. I repeat, once you get the question, compare it with the original figure. Where is AOB? Children, here is your AOB, the one which I'm highlighting in white color, isn't it? This is your triangle AOB. Where is your triangle COD? Here is your triangle COD, right? So once you highlight it, you get a clarity that these are the two triangles which I need to prove similar. See, is it clear? Shazia? That side? Clear? This side? These are the two triangles which I have to prove similar. Online students, Purva, Caitlin, understood what we have to show similar. Now, you must be thinking, Array, this is a quadrilateral. If it was a parallelogram, or if it was a rhombus, or a square, or a rectangle, you could have shown two of the angles equal. How? By using the properties of two parallel lines, isn't it? Alternate interior angles are equal, or corresponding angles are equal, or the sum of the co-interior angles are 180 degree. Any one of the three properties we could have used to show similarity. But here the problem is neither the quadrilateral is a square, rectangle, rhombus, or parallelogram. So there is no chance of proving the angles are equal because the properties of parallel lines does not exist here. Isn't it? ABCD is simply a quadrilateral. We don't have any idea whether AB and DC are parallel, whether AD and BC are parallel. No idea about it. So never even think of using properties of parallel lines. Children, now in order to cover up that drawback, they have given you the ratio of COAO, DOBO, so that we can apply side angle side axiom and show similarity between those two triangles. Okay, I'll repeat that whole sentence. In order to cover up that drawback of opposite sides being not parallel to each other, very well in advance, in the question itself, they have given you the ratios of COAO, DOBO, so that you can make use of which axiom? Side angle side axiom and prove similarity. Okay, now I'm coming into the depth of the question. Children, how to use side angle side axiom? First of all, what you need to do, you need to draw those two triangles which are going to prove similar separately to get a clarity. Okay, so I'm going to draw it here. On a smaller scale, I will draw it. Okay, so this is your first triangle, DOC. And the second triangle is what? Triangle AOB. Triangle AOB. Now you all know since these two lines or these two diagonals AC and BD are intersecting each other, the vertically opposite angles must be the same. Do you all agree with it? Huh? If you notice, children, this AC and DB, they both are two diagonals which are intersecting each other at point O, isn't it? So obviously, the vertically opposite angles will be equal, right? So I can say angle DOC is equal to what? Angle AOB. Huh? Angles are equal. So one of the angles in both the triangles are equal. Now there is no chance of showing one more angle in both the triangles to be equal. There is no chance. And the reason I already mentioned before, since it is a quadrilateral. Okay, properties of parallel lines cannot be applied here. So one more angle to be proved to be equal is not possible. So what is the other way? Children, see this. They have given you the ratio of CO and AO. Where is CO? CO is over here. Where is AO? AO is over here. What is the ratio of CO and AO? It is 1:2. That means if CO is one part, AO is what? Two parts. Right. Similarly, DO upon BO is what? 1/2. Where is DO? Over here. DO is one part and BO is equal to how many parts? Two parts. Right. So if you notice, the ratios of the two corresponding sides are equal in these two triangles, isn't it? When I say DO upon OB is 1/2 and CO upon OA is equal to 1/2, and the included angle are equal. Are you able to recollect, children, what I taught you before? The ratios of the two corresponding sides are equal, and the included angle in both the triangles are also equal. In that case, we can say the given two triangles are similar to each other. Does that make sense for all? Caitlin, is that clear? So the first statement, isn't it, children? Because CO and AO happens to be corresponding sides. DO and OB happens to be corresponding sides. They both are in the same ratio, 1 by 2, 1 by 2. And at the same time, the included angle is also what? Equal. So we can say they both are similar to each other. So first statement would be what? CO by AO is equal to 1 by 2, which is given to us. What would be the second statement? DO by BO is equal to 1 by 2. And that is also given to you. Jeevan, you followed it? Then angle DOC is equal to angle BOA, right? What is the reason? They both are vertically opposite angles. They both are vertically opposite angles. So which axiom helped you to prove similarity between the two triangles? Which axiom? Side, angle, side. Okay. So you will write your triangle AOB similar to triangle COD. There is no need to figure out which are the corresponding vertices, because they had given you well in advance AOB and COD to be similar. The corresponding vertices were already named in the question itself, isn't it? So you can directly write AOB similar to triangle COD. And then mention the axiom which you have used. What is the axiom? Side, angle, side, axiom. Proved. Now let's SAS criterion also you can write. Rule, axiom, criterion, postulate, anything. Nobody is going to watch for that. They will just see whether SAS is there or not. You simply write SAS, you will get marks. I'm talking about the board corrections, because the board corrections are very lenient, children. Okay, you write essays and come back, you will get full marks. Okay, that's how the board is. But for school examinations, your teacher will always see criterion. Spelling is correct. CRITERON. Spelling is wrong and she will cut your 1 mark. You have to be that careful in school exams. Right? Yeah, even I am the same. No different. Okay. Purva, who is your math teacher? Chitra ma'am?
Yes, sir.
Yeah. Okay. Now we have to show OA into OD is equal to OB into OC. What we will do? We will write the thumb rule. The moment we write the notation form, what should be the next step, Milan? Oh, thumb rule. Okay. Oh, okay. No, I was thinking what you're showing me. I'm asking you a question and you're showing me this. Okay. So let's write the thumb rule. What is the thumb rule, children? It is AO upon CO or OC is equal to OB upon OD is equal to AB upon CD. Right, children? I'm just pairing the corresponding sides AOCO, OBOD, and ABCD. The best way to find the corresponding sides. Okay. Now they are asking us to show OA into OD. Where is OA? I'll just highlight it. Huh? Where is OA? Over here. Where is OD? OD is over here. Then OB over here. OC over here. Oh, children, it's just a simple case of cross multiplication of the first and the second ratio. Isn't it? Children, if I cross multiply, if I take these two ratios, AO upon CO is equal to OB upon OD. What if I cross multiply both the sides? Huh? I'll be getting AO into OD is equal to CO into OB. Hence proved. Any help required, children? Am I clear with this? Joanne, you already did. What about the others? Jeevan? Online students, please, children, before I start with the next, please ask me if you have any doubt. Was I, children, am I explaining properly? Sure, no? I think I'm covering all the points and I'm going really slow. Right? If you feel that, I increase my speed in between, just let me know. Okay. When I spoke about quadrilaterals, did you understand what are the limitations of? No, they haven't mentioned that it is a square. Then you cannot take it as a square. Right? If you take it as a square, automatically you will get a temptation to consider opposite sides to be parallel. Then you will get an idea, if opposite sides are parallel, alternate interior angles must be equal, isn't it? That means you are moving into a wrong direction. As long as they haven't specified the name of the quadrilateral, square, rectangle, parallelogram, rhombus, you cannot take it like that. Okay, they have simply used the word quadrilateral. That means the figure which you take should be what? Just a minute, children. Yeah, as long as they haven't mentioned, you should take it as a quadrilateral with none of the sides being parallel to each other. Okay, fine. Then we proved similarity by using SAS axiom. Then we took the first and the second ratio. I mean, from the thumb rule, we took the first and the second ratio, cross multiplied it, and we got the answer. Right? Now, let's solve the fifth question. Very good, children. Chalo. Next question. This is also totally theoretical. No numericals involved. Read it. In triangle ABC, angle ABC is equal to twice angle ACB. Bisector of angle ABC means the opposite side at point P. You have to show that CB upon BA is equal to CP upon PA. Right? This is your triangle ABC. Read the question again if you haven't understood. Angle ABC is equal to twice angle ACB. Children, you know where these two angles align. Where is angle ABC? It's over here. Just highlight it for your reference. Where is angle ACB? That is over here. This is angle ACB. Now they have given you a correlation between angle ABC and angle ACB. What is that correlation? Angle ABC is equal to twice angle ACB. Let's convert that sentence into a mathematical equation. Okay, how will I do that? I'll write it here. Angle ABC is equal to 2 times angle ACB. As simple as that. Okay, so children, imagine. Now, if you're not comfortable dealing with the big names of angles, okay, if you're not comfortable dealing with the big names of angles, you do one thing. You consider the angles in terms of x and y. Okay, in terms of x and y, or at least in variable x. So what I'll do is, I'll just assume this angle ACB as x. I'm just assuming angle ACB as x degree. So angle ABC will be what? Angle ABC will be what? 2 times x degree, isn't it? I'm just naming. If you want, I can write and show it to you. I am just assuming angle ACB is equal to x. This portion, children, angle ACB is equal to x. In that case, can't I say angle ABC will be equal to 2 times x? Yes, and I will label it over here also, 2 times x. This part is clear. Then bisector of angle ABC. Children, bisector. What is the meaning of bisector of an angle? Dividing an angle into two equal parts, isn't it? Bisector of which angle, children? ABC. Where is angle ABC? Over here, right? This is your angle ABC. So bisector of angle ABC means the straight line which is going to divide that whole angle 2x into two equal parts. Children, I'll repeat. In the sentence which I framed now, there is a small hint. What is this green colored line? The bisector of angle ABC, isn't it? What was angle ABC? It was 2 times x, isn't it? So that 2 times x is divided into two equal parts. So can't I say this portion will be equal to x and the remaining portion, that is this brown colored portion, that will also be equal to x. Do you agree with that? Yeah. The whole angle was how much, children? 2 times x. Now the green colored line is what? The bisector. And the bisector is dividing 2 times x into x and x. Understood, Sachin? Okay. Sean? Albina? Yeah. Then what they are asking us to show, bisector angle ABC means the opposite side at point P. Okay, they are meeting the opposite side. No, opposite side is what? AC. And where they are meeting? At point P. Okay, so I'm labeling that point of intersection of the green line and the yellow line as what? P. Once you understand the figure, rest becomes easy. See this? They are asking us to show CB is to BA is equal to what? CP is to PA. See, I'll erase this part and I'll write what you have to prove. You have to prove CB upon BA is equal to CP upon PA. Okay, it's quite obvious, no, children? CB upon BA, CP upon PA, they both are going to be what? The corresponding two similar triangles, isn't it? We don't have any clue of which two triangles CBBA, CPPA belong to, isn't it? To which triangles they belong to. So first of all, let's find out to which two triangles the CBBA, CP and PA belong to. Once we find it out, we can show that both the triangles to which these four sides belong to are similar to each other. Once we show similarity, we will use the thumb rule and then show the required result. Okay, now you have to tell me, children, which two triangles you have to take. CBBA, where is CB? CB is over here, right? I'll just highlight it in blue color. BA is where? Over here, right? So CBBA. CB and BA, I think it will belong to the big triangle ABC, isn't it? Yeah, AB and BC will belong to big triangle ABC. Fine. Then, so I'll do one thing. I'll just draw those two triangles here. The first triangle is obviously A, B, C. CP and PA. CP, where CP is over here, right? And then PA. Okay, CP and PA. Don't you feel CP and PA belongs to triangle PCP or CPB? Yes. CP and PA. Oh, okay. CP and PA is what you have to draw. Okay. So CP and PA. CP and PA. CP belongs to triangle BPC and PA belongs to triangle BPA. Children, what I feel is you have to take the two smaller triangles. Don't you feel so? You have to take the two smaller triangles. See, we will just do a trial and error technique. I think they will belong to two smaller triangles and we will have to show that the two smaller triangles are similar to each other. You know why I got a clue? or why I got a thought like that? This is your triangle. This is your triangle ABP. Okay. This is your triangle ABP. And this is your triangle. This is your triangle BPC. Okay. These are the two triangles. Now, if you, yeah. Okay, let's continue, children. Yeah. So, children, I felt so because CB is a part of triangle BCP. Then BA is a part of triangle BAP, right? CP is a part of triangle BCP and PA is a part of triangle BAP. Do you agree with this? Yes. So children, wasn't it easy for you to understand to which two triangles these both sides belong to? It was easy, right? And this is how you have to predict, children. There is no direct formula to predict which two triangles you can take and prove similarity. You have to do hit and trial method. Okay, at times the first attempt may go wrong. Once you realize it is wrong, just erase that diagram and go for the other pair of triangles. You will get it. Okay, now see, children, how to show that these two triangles are similar to each other. If you notice, angle ABP is what? X, isn't it? So I will label that X over here. Angle PBC is what? X. So I will label that also over here. One of the angles in both the triangles are equal. Then, if you notice, angle where is the angle, man? Are we missing something? Illada, common side will not come. That is congruency. No, man, it is not perpendicular bisector. It is just bisector. Only this angle will be divided into two. This is an isosceles triangle because these two angles are equal. 180 minus 2x. Are we missing some important point? Opposite sided point P. Are we missing some important point, children, somewhere? We are not thinking about this angle, right? We know angle PCB is what? X. This angle is equal to X. This angle would be children, just think over it. X to X, X to X. 80 triangle ABC, small triangle ABP. Now, automatically, the first vertex will be what? The first vertex will be A itself, right? So A goes with A. And what is the required axiom? It's side, angle, oh sorry, angle, angle, axiom. Which axiom it is? Angle, angle, axiom. So once you write the notation form, we can use the thumb rule. What is the thumb rule? The ratios of the corresponding sides are in proportion. I'll just erase this diagram. Okay. Let's write the ratios of corresponding sides in proportion. So you get AB upon AP is equal to BC upon PB is equal to AC upon AB. Right? Now what we will do? We will see what was the result to be shown. BC upon BA. BC upon BA. Where is BC upon BA? Are we getting it? No. We are getting BC upon PB. Right? Just a minute. I have written AB upon AP is equal to BC upon PB is equal to AC upon AB. This is what we have written. Now we have to show CB upon BA is equal to CP upon PA. CP upon PA is here. CP upon PA, that is also not here. Okay. Where is the original figure? I erased it. This was the original figure, no? A, B, C. Last part, no children. We'll get over fast now. Last part. This is X. This is X. This is also X. And how much is this? This is 2 times X. Right? Now, children, can't I say, since these two angles are equal, X and X degree, these two sides will be equal? Don't you feel so? PB and PC will be equal, right? PB and PC will be equal. Why? Because this triangle which you have drawn, triangle PBC, it's an isosceles triangle. You all agree to that? It's an isosceles triangle because this is X and this is X. So obviously PB and BC are equal. PB and BC are equal. Yeah. So now, can we use that concept in showing the result? CB upon BA. CB upon where is BA after this one, right? Let me take the first two ratios. AB upon AP is equal to what? BC upon BB. Children, we need a CB upon BA. CB is over here. Shall I write this AB on the right hand side denominator? Shall I bring it? And shall I bring PB towards the left hand side numerator? So I think it will become PB upon AP is equal to BC upon AB. Is this correct? BC upon AB. Now the left hand side has got some problem. PB we have. PB can be replaced with PC, right?
So we can take triangle ABP and ACB. Sir.
ACB.
While writing, the triangle ABP is equal to ACB. Triangle ACB.
ACB.
Like that, if you write, we'll get.
Okay, fine. Now then you just write it in that way.
I wrote.
Are we getting the result, children? PC upon AP is equal to BC upon AB. Okay, I'll explain the final part again. Final part again. Till here, everything was fine till this step. Everything is fine. Now, when I looked at the final result which we have to bring, CB upon BA is equal to CP upon PA. Children, I was noticing at this part, I was just noticing this part. I had got AB upon AP is equal to BC upon PB. Now, they want BC upon BA. Here BC is line, isn't it? Here BC is line and here AB is line. So if I want to BC upon AB, what should I be doing? I should be shifting this AB from the left to the right hand side denominator, right? So where will this PB go? PB will go from the right to the left hand side numerator, isn't it? So it becomes PB upon EP is equal to BC upon AB. I am done with this portion. I am done with this portion, BC upon AB. But still on the left hand side, I have got some differences. What is that difference? They wanted CP upon PA. I am having BP upon PA. AP or PA both are same. I am having PB upon PA. So children, PA is fine. That is required. But what about this PB? What about this PB? You know, PB and PC, they both must be equal. Why they both must be equal? Because I just showed that triangle PBC is what? An isosceles triangle. So both the sides are equal. So what I can do? I can replace this PB with what? PC. So I get PC upon AP is equal to BC upon AB. Hence proved. Fine. Hence proved. Second part. AB into BC is equal to BP into CA. AB into BC is equal to BP into CA. Now that we can take the second and the third ratio, right? So in the second part, for proving the second part, AB into BC is equal to BP into CA. How can we show that? Shall I take the second and the third ratio from BC upon PB is equal to AC upon AB. Shall I cross multiply both the left and right hand side? So what will I get? AB into BC is equal to AC into BP. Hence proved. I just took the second and the third ratio and I proved it. Okay. Children, did you all follow it? When a teacher goes to, when a teacher teaches in school, they will be well prepared from home because they don't have so much of time to experiment. So the way they will teach you is taking the bigger triangle, taking the smaller triangle, directly they will show you the proof. Okay, they will never show you the other side of the story, isn't it? But as long as you are not aware of the other side of the story, because the first thing that you're going to look out for is to which two triangles BC, BA, CP, PA belongs to, right? You will never in your wildest dream think of that the smaller triangle was an isosceles triangle and those two sides were equal. And then ultimately you will go and replace that PB with PC, isn't it? You will never think of that. So the other side of the story is never explained in school. And that is just because the teachers are always running short of time. Okay, they don't have so much of time to do experiments in school. So, but here, since we are getting time, let's experiment on it and let's try to understand. There exists a method called trial and error, where you try. What happened? There is always a trial and error method where you try with your own ideas and you don't get it. So when you don't get it, there is always a second attempt to it. And definitely in the second attempt for similarity sums, you will get it, children. And this was one of the best examples to it. Because you can't get all the ideas together, right? You will never even think of using that isosceles triangle property for the smaller triangle and then substitute it, right? But in school, when you learn, you directly learn it in A to Z method. You start from a bigger triangle, end at smaller triangle. In that smaller triangle, you apply isosceles triangle property and you solve it. But that doesn't happen with you guys when you sit in the examination hall. At that time, different thoughts will be going on, isn't it? And you feel that, okay, fine, these two small triangles is going to help me, but it does not help you. So at that time, you should have the courage to not panic and go with the second option. Okay. And in the second option, you will suddenly jump into that idea where the two sides are equal. Okay. Yeah. Enough for the day, children. Now we will meet tomorrow. As long as we have proved that sums without any numericals, children, it is going to take time, and hardly in a session, 4 to 5 sums will be solved. Not more than that. Okay, not more than that. Don't expect. But once we start solving numerical sums, within 5 minutes, each and every sum will be solved. Okay. Fine, children. So thank you so much. See you tomorrow at 6:30. Bye.
Thank you,
Good night,
sir.
children. Take care. Yeah.
Thank you, sir.
Bye, children. Bye.
Bye.
Thank you, sir.